It's another math day here with teacher Jenny. Join me for another topic. This time we're going to talk about unit circle. Suppose that we are going to find the coordinate of the intersection point of the terminal side of the angle and the unit circle. So if this is our terminal side of the angles and the unit circle here, if we are going to find the coordinate of the intersection point of each, then what we are going to look for is these points here. And we are going to consider that what we have here is a unit circle. So meaning to say that every radius here is going to be equal to 1. So notice the terminal sides of our angles created here are connected to the center and on the point on the circle. So that means to say that every terminal side here has a measure or has a length which is equal to 1. So let us start with our quadrantal angles. So once we say quadrantal angles, those are the angles on the x and y axis. First quadrantal angle here is the 0 degree or the 360 degrees. So this one here, the point, this point here is gonna be 1, 0. Why 1, 0? Because our x value here is gonna be 1 because our radius measures 1. So since this is coming from 0 or the origin, once we say this, the length of that one is 1, then that means that this value of x here on this point is a 1. We do not move up or down, so our y value is a 0. Next quadrantal angle is the 90 degrees, this one here. Our point of intersection of this terminal side together with our unit circle is gonna be with, since we are on the y-axis, we have that as 1 because again, our radius is equal to 1 here. So since this is coming from the origin, going to this point here, our value is 1 on y. So that is why we're having here 1, and then we do not move to the right or left from the origin. So this is a 0 on, a 0 on x and a 1 on y. So we now move to the next quadrantal angle. We have 180 degrees in which the terminal side is this one here and this point here. If this is the terminal side, this means that this is also the radius which is equal to 1. Our value in x here is negative 1 because this is on the negative x-axis, so this is negative 1. So the value of or the coordinate of our 180 degrees is gonna be negative 1 and a 0. Let's move to the next quadrantal angle. So we have this one here, the 270. Again, this one is r is equal to 1. This means that our y value here is negative 1. So our coordinate for 270 degrees is 0 on x, negative 1 on y. So this time we are now going to have our special angles here. Special angles are the 30 degrees, 45 degrees, and 60 degrees. So let's try to find our coordinate of the intersection of this terminal side that is created, that is creating an angle of 30 degrees with respect to the positive x-axis. So since this is our angle 30 degrees, this means that our coordinate here, the value of our x is gonna be where this point is in line with. So most likely this is the x that we wanted to know. And then the y value of this point is gonna be where the value of y here is, or what the value of y here is. So if we try to look at that, this part here, we are trying to form a right triangle with an angle 30 degrees in here. So if this is 30 degrees, of course, this will be a 60 degrees. Now, if we wanted to know the values of the x and y, or the coordinate of this terminal side, we have to make sure that this one, we know that r is 1. Going back to the trigonometric not trigonometric ratios, but sorry in the words, but looking back to the 30, 60, 90 special right triangle, this is our triangle. If this is gonna be 90 degrees and this shorter side is gonna be opposite that 30 degrees angle, and the longer side is the one which is opposite to the 60 degrees angle. Notice that once we say 30, 60 degrees, 30, 60, 90 degrees triangle, we do have a special ratio of the side of our triangle here. We have to know that this opposite to 30 degrees is going to be with 1, and the hypotenuse, which is opposite to the 90 degrees, is going to be always with 2, and the one which is opposite to 60 is a square root of 3. So if you try to look at that, it's a matter of 1, 2, 3, but only that the one opposite to 60 degrees is with a square root. Now, notice that our radius there is 1, which is also the hypotenuse of the triangle created out from the 30 degrees. So this means that if we wanted to make use of these values, we have to divide this 1 by 2 to make this equal to 1. And then, of course, we also divide each of the values on the side here by 2. So the new value that we are considering here is going to be 1 on the hypotenuse, 1/2 opposite to 30, square root of 3 over 2 opposite to 60. So what will be our coordinates? So we will be checking what will be the value of the length here, because automatic, whatever is the length on this side here will be our x value on that point. And whatever will be the length of this one here, the vertical one on the triangle, this will also be the corresponding length of the y. So, transferring the values here, we've got 30 degrees, which is opposite to 1/2. That means to say that this length here is 1/2, while this one here is the square root of 3 over 2. So, automatically, this will also be the value of x here, which is square root of 3 over 2, because we're coming from the origin. And then, we also have our 1/2 on the y. So, considering these values, we may also find the different coordinates here for the 60. So, if you have here, if you try to look at the 60 here, for this 60 degrees, we can utilize the values of our 30, 60, 90 degrees triangle that we had a while ago. So, we have here 30 degrees opposite to the shortest side, and we have 60 degrees opposite to that longer side. So we have here the value opposite to 30 degrees is 1/2, while the one opposite to 60 is square root of 3 over 2, and the opposite to 90 is a 1. So considering those values, so we have here, we can form a right triangle out from the vertical line and the horizontal line here. We have to know the value of x here so that we can name the coordinate of the intersection point of our terminal side, and so with the unit circle. We need to know also the value of y here. So going back with our triangle, we have to know that this is 60 degrees, and of course this one is at 30 degrees. So going back to the triangle, we have 60 degrees opposite to that one is square root of 3 over 2, while on 30 degrees opposite to that one is a 1/2. So which means that from 0 to this x here, we have the value which is 1/2, and from 0 to the y here, that is square root of 3 over 2. Let us go back to the 45 degrees. So if this will be our terminal side for the 45 degrees, we are going to look for the coordinate of the intersection point of this terminal side and so with a unit circle. So on the 45 degrees, 90 degrees special right triangle, we are to consider that the values here of your side as well, with the ratios of the side, will be somewhat like this. Let me just finish this one. So this will be a matter of 1 and 2. So we have 1, 1 here, opposite to the 45 degrees. And then we have the 2 here, but this time we have the square root of 2 on that particular hypotenuse. That will be our ratio of the sides of the 45, 45, 90 degrees. We wanted to have it because this is a radius of 1 here, which is gonna be the hypotenuse, because if we try to draw the vertical line connecting to the horizontal axis here, we have that opposite to the 90 degrees. So 1 there, or the radius, is gonna be the hypotenuse as well. So since our hypotenuse is 1, we are going to make this hypotenuse also equal to 1 by simply dividing this by square root of 2. In this manner, this will be equal to 1. Since we did divide this 1 by square root of 2, we do the same thing on the other side. So this time we have a radical symbol at the bottom part. This cannot be. So we do rationalize that 1 by simply multiplying by square root of 2 over square root of 2. This is now 1 times square root of 2, square root of 2, over square root of 2 times square root of 2. That will be square root of 4, which is a 2. Also the same thing, this is also equal to square root of 2 over 2. These are the values that we need to consider under 45, 45, 90 degrees. So looking back, this is now 45 degrees. This is also 45 degrees here. So which means that opposite side to that one is square root of 2 over 2, while the opposite of that other 45 degrees is square root of 2 over 2 as well. So we now have our coordinates as square root of 2 over 2 and the square root of 2 over 2. Let us now go to the second quadrant. We have 120 degrees here, and we wanted to find the coordinate of this intersection point between the terminal side creating that angle and so with the unit circle. So if you try to look at that, the ones that we have on the special right triangle are only with 30, 60, 90 degrees, 45, 45, 90 degrees. We don't have 120 degrees. So this time we will be utilizing the reference angle. Since this is on the second quadrant, reference angle, we just have to get that one by simply having 180 degrees minus 120 degrees, which is the angle. This one is our angle, which is 120 degrees. And to find the reference angle, we just have to do that one, which is equal to 60 degrees. This one here is 60 degrees. That's our reference angle. So we can now create our right triangle here. This means we need to know our x value here. What is that x equal to? And what is this y equal to? So again, looking back at the values of our 30, 60, 90 degrees, if you still recall that one, this is 30, this is 60 degrees, and then opposite to 30 degrees is 1/2, because what we are having here is a unit circle with radius equal to 1, which is also the hypotenuse, and opposite 60 is square root of 3 over 2. So utilizing those values, we have here opposite to 60 degrees, that will be square root of 3 over 2. And then opposite our 30 degrees, which is this one here, 30 degrees, opposite to that one is 1/2. So which means that this x value is 1/2, but wait, this should be negative because it lies on the second quadrant and the x here is a negative. So writing now the coordinates, we have our y here square root of 3 over 2 as well. Writing the coordinates now, or the coordinate now of our 120 degrees, we have that as negative 1/2 and square root of 3 over 2. You may do the same thing on the others. You can get the reference angles and then continue this one. You know the drill. You know how to get those values using our 30, 60, 90 degrees, and so with a 45, 45, 90 degrees. So again, once you are on the second quadrant, third quadrant, fourth quadrant, try to get the reference angle and then go back to the ratios of the special right triangles. So once again, this is your teacher Jenny saying good luck and practice, and please do not forget to subscribe and hit the notification bell.